Okay. Example 24 wants us to find all angles between 0 and 2 pi, which satisfy the equation 2 sine squared of x. Um, so 2 sine squared of x equals 5 cosine of x minus 1. So now this becomes a little bit more complex. So we have a squared function and a regular function. Okay, so um, there is a this is a quadratic equation whether you think about it or not, because we got a square and a regular. So think of this kind of like this is like an x squared and this is like an x, like 5x and 2x squared, except for the fact that one's a sine and one's not. So we want to think about this like a quadratic equation, but we have to get all of the parts, the trig functions, to be the same one. So we got to think about a way to do that. Now, if we remember back to our different identities, how we can swap things, we do know that cosine squared plus sine squared equals 1. So we could replace sine squared with 1 minus cosine squared, and that would allow us to everything to be the same. So what I'm going to do is I'm going to start off, and I'm going to get 2 of the 1 minus cosine squareds equals 5 cosine of x minus 1. So when I multiply this out, I'm going to get 2 minus 2 cosine squared of x equals 5 cosine of x minus 1. So now what I'd like to do is get everything on one side, and so that I can make a quadratic equation from it. So I'm going to move all of this stuff over. It doesn't matter which direction you go. I just like to have my squared term normally being positive. It makes things like factoring and whatnot easier. So I'm going to have the 0 will be over here. So this becomes a 2 cosine squared on the other side. My 5 cosine of x is still here. And then this, the positive 2 becomes a negative 2. With that makes a negative 3. So now what I'd like to do is try to figure out how am I going to solve this equation. Now, firstly, you could go and you could use the quadratic formula. Realize now that it's not going to be solving for x. It's going to be solving for the cosine of x. So you're going to have to still do a little bit more work from there. But that's an option. You could also factor. I would like to factor. I see that, I've got 2 and 3 kind of makes 6, which is really close to 5. So that could be a really big hint for me. So instead of being like 2x, I'm going to have 2 cosine of x as one of my options. And the other side is going to make a cosine of x. So it's the same idea as factoring with other variables, except now we're using functions because we're noticing that we can do that. So let's look at the other parts here. The negative 3, again, the two numbers that I plug into each side of these has to make negative 3 when we multiply. As I was saying before, this number is really close to 6. So I'm going to make 6 and then take 1 away from it. So we got the minus x and the 6, and that makes everything nice and easy. So I'm going to keep going. So again, we're going from 0 to 2 pi. So let's look here. So based off of what I just wrote, two possibilities emerge. Either 2 times the cosine of x minus 1 equals 0, or the cosine of x plus 3 has to be 0. So this is the only way that this equation is going to make 0. Is either this part works or that part works. So we got to figure out what makes each of those work. So let's go to the left side. So we're going to solve for it. We're going to get 2 cosine of x equals 1. We're going to get the cosine of x is going to be 1/2. So if we think about where does this happen on our unit circle, so cosine of x it'll be at these two places. So it's going to be a half at, let's see, that would be at pi over 3. Is that what we're doing? We're doing 0 to 2 pi. So we're going to have at pi over 3. And it's also going to happen at 5 pi over 3. So these are our two places where cosine is going to be a half. Now, if we go to the other side, it's only going to happen when cosine of x equals negative 3. This can't happen. There are no solutions to that. Now, because cosine of x can only be as low as negative 1. right? We would have to have altered the cosine graph in order to get it down that far. But pure cosine of x cannot be -3. It can't be any less than -1 or more than 1. So we don't get any answers from that side at all. So those are extraneous solutions. Just because that's a condition of the problem doesn't mean that it has to work, right? We just know logically that the only way that this equation could equal 0 is if either the cosine of x plus 3 equals 0, which it can't, or 2 cosine of x minus 1 does equal 0. That can happen. So this equation does have two solutions, but it gets none from the other side. This can happen quite often when we're dealing with quadratic equations because two answers must emerge. They could be the same, but two answers must emerge. Sometimes some of them don't make any sense. And in this case, part of them wouldn't make any sense.